Following up our first video on the introduction of organic chemistry, today we'll learn about our first homologous series, which is alkanes. So in this video, we will be covering the structure of alkanes, how do we name alkanes, the characteristics, physical properties, as well as the chemical properties. So before we head into the video proper, let's just do a quick recall on what we learned in the previous video. So we learned that there are four homologous series. The first one will be alkanes, which is what we will be touching on today, followed by alkenes, alcohol, and carboxylic acid. Okay, so the naming of organic compound can be divided into two parts, which is the prefix and the suffix. So the prefix, which is the first part, tells us how many carbon atoms there are in each molecule. So each number of carbon atom will correspond to one prefix, which is Me, E, Pro, Bu, Pent, for 1 to 5 carbon atom respectively. Then the suffix will tell us about the homologous series that the compound belongs to. So in this video, all of our organic compound will end with ANE because it's alkane. So what are alkanes? Alkanes are a homologous series of hydrocarbons which contain only carbon-carbon single covalent bonds. So let's recall that hydrocarbons are organic compound that contains only carbon and hydrogen atoms and nothing else. So it's only carbon and hydrogen atoms. So you can see in this structural formula, alkanes only contain all their single bonds. Each carbon is only single bonded to the next carbon, and so on. And all alkanes will have this general formula of CnH2n plus 2. Alright, CnH2n plus 2. So N corresponds to 1, 2, 3, or 4 depending on the number of your carbon. So the overall molecular formula will be dependent on the number of carbon atoms that I have. So looking into this molecular formula in depth, if alkane only has one carbon atom, then N equals to 1. So if we substitute that into the general formula, we will get C1 H 2 multiply 1 plus 2, which will give us CH4. Another example, if alkane has 2 carbon atoms, then N equals to 2, and C2H6 will be the molecular formula for a alkane with 2 carbon atom. Okay, so this table shows the summary of all the different molecular formula for alkanes which have 1 to 5 carbon atoms. Now that we know how to write all the molecular formula, let us learn how to name the alkanes. So as we know earlier on, all alkanes will end with the suffix of A and E. So we expect the name to end with A and E with the corresponding prefix. So once again, the prefix is determined by the number of carbon atoms that we have. One carbon atom will give me a meth, 2 atom will give me a eth, 3 prop, 4 but, and 5 pent. So putting the prefix and the A and E suffix together, we will get the name of the various alkanes. So we have methane, ethane, propane, butane, and pentane. So this is a summary for all the molecular formula as well as the name. So if one carbon atom, we have methane with the molecular formula of CH4. Two carbon atoms will have ethane with the molecular formula of C2H6. Three carbon atoms, we have propane with the formula of C3H8. Four carbon atoms, we will have butane, C4H10. And finally, 5 carbon atoms, we have pentane, which is C5H12. So if you look at the molecular formula, you'll realize a pattern. From one to the other, there is an increase in this CH2 unit. So for methane, if I add a CH2 unit, I get ethane, C2H6. And this formula will be one CH2 unit short of the next. So if I add CH2, I will get propane. From propane, if I add CH2, I get butane. And from butane, if I add CH2 again, I get pentane. So what we realize is that down the homologous series, one member will differ from the other by just CH2. Now we look at the structural formula. So the structural formula will show you how the atoms are arranged in that particular molecule. So for alkane, it's really straightforward because it's all single bond. They will just go across linearly, right? So looking at across all the different structural formula, we only see carbon-carbon single bond in every single one of them. So to summarize the characteristics, all alkanes have the same general formula of CnH2n plus 2, and every member of the alkane homologous series will differ from next by a CH2 unit. And most importantly, alkanes are what we call saturated carbons. Okay, saturated carbons. So what are saturated carbons? The alkane, they have all their carbon atoms being bonded in single bonds. So every carbon is bonded to 4 other atoms. So the carbon atoms can no longer accept any new bonds with any more additional atoms. So they cannot form new bonds, and this is said to be saturated. Saturated in layman term means it's full, it's fully filled up. So alkanes cannot form new bonds, so they are known as saturated hydrocarbons. Let's move on to the physical properties of alkanes. Alkanes have low melting and boiling points. They are insoluble in water, however, they are soluble in organic solvent. So alkanes are essentially just simple covalent molecular structures. So if you recall from our previous topic, simple covalent molecular structure have all these properties of having low melting point and boiling points. So alkanes will have typical simple covalent molecule properties as well. So let's us look in depth into each of these properties. So down the homologous series, right, alkane will show a general trend in the changing of their physical properties. So which are the properties that we can observe such trends? It will be the melting and boiling points, the viscosity of the alkanes, and the flammability of the alkanes. So in general, all these changes are due to the increasing size of the alkane molecules. So let us now look at each of these trends in that. So firstly, we have the melting point and boiling point. So the gradual change that we observe is that the melting point and boiling point, they will increase down the series. Okay, so from methane all the way down to pentane, we realize that the melting point as well as the boiling point, they will increase. So why is this so? This is due to the increased number of atoms. So as you recall, if we have more atoms, this will cause the forces of attraction between the molecules to get stronger. So as the molecule gets bigger, the forces of attraction get stronger. So to break from one physical state to the other, we will need a larger amount of energy to overcome these forces. So from melting point, from solid to liquid, okay, for the atoms to break through their physical state, we will need more and more energy down the series. Similarly, for the boiling point, okay, from liquid to gaseous state, we will also need increasing amount of energy. So because of their very, very low melting and boiling point, alkanes are mostly gaseous state at room temperature and pressure, with the exception of pentane, which is liquid at room temperature and pressure, because the melting point it's at 36, whereas room temperature and pressure is 25 degrees Celsius. Okay, so once again, the melting point and the boiling point will increase down the series due to the increasing forces of attraction between the molecules. Next up, alkenes are more viscous down the series. So what do I mean by viscosity or being viscous? So viscosity measures the tendency for a fluid to flow. So the more viscous it is, the harder it is to flow. So by becoming bigger, alkanes have increasing forces of attraction between the molecules. So it's very hard for the molecules to break apart from each other. As a result, they will flow less easily as their molecular size increases. Alright. Thirdly, alkanes are less flammable down the series. So alkanes in general are already flammable, but as the number of carbon atoms increases, the alkane become less and less flammable. Also, larger alkanes will produce a more smoky flame when they undergo incomplete combustion. Okay, so a smokier flame will only happen when incomplete combustion occurs. Okay, let's move on to the chemical properties. So alkanes are generally unreactive. So this is because alkane molecules only contain your single carbon-carbon bond and the single carbon-hydrogen bond. So these bonds are pretty strong and difficult to break. So alkanes tend to just stay as they are and not undergo chemical reaction. However, having said that, alkenes will undergo only two different sort of reaction, which is combustion and the substitution reaction. So now let us look at each of these chemical reaction in depth. So alkenes will burn easily in excess oxygen. So take note, it has to be excess oxygen, if not it will be an incomplete combustion. So they burn in excess oxygen to produce carbon dioxide and water vapor. Okay, why water vapor is because of the very high temperature of combustion. So water will be presented in the form of water vapor in the gaseous state. So the general formula for combustion will be alkane plus oxygen, giving me carbon dioxide and water vapor. Alkane plus oxygen will give me carbon dioxide and water vapor. So combustion is highly exothermic. So recall that exothermic means giving out of heat energy. Okay, so alkane actually makes very good fuel. So if you relate it to our common day-to-day life, you will realize that all the fuel around us are actually made out of alkanes, such as methane or our petroleum fractions for petrol. So all these are very good sources of fuel because of this highly exothermic property of alkane. So let's take a look at a few examples. So methane, applying it to the general formula, so we have methane plus oxygen will give me carbon dioxide and water vapor. So you're looking at the molecular formula, we will have CH4 plus 2 molecules of oxygen will give me 1 molecule of carbon dioxide and 2 molecules of water vapor. So how do I balance the equation easily? Firstly, I'll balance using the carbon atom first, then I'll balance the hydrogen atoms, and I can easily balance oxygen to obtain a balanced chemical equation. Okay, another example will be butane. So butane will burn in oxygen once again to give me carbon dioxide and water vapor, right? So this is the chemical equation which is balanced with the appropriate state symbol. So butane will be gaseous state, oxygen is gaseous state, and I'll get carbon dioxide gas and water vapor due to the high temperature. We will now look at the second reaction that alkane can undergo, which is the substitution reaction. So this reaction needs very specific condition, which is UV light, the ultraviolet light. So alkenes will react with halogen. So recall that halogen is the group name for your group 7 element, such as chlorine and bromine. And all this has to happen in the presence of your ultraviolet light. If not, nothing will happen. So an example would be methane and chlorine in the presence of UV light. We get chloromethane and hydrogen chloride. Okay, so the product will pluck off the front part of the name from the halogen and add it to the alkane that we have here. Looking at the molecular formula or the chemical equation, we have CH4 methane plus my chlorine molecule Cl2. In the presence of UV light, I get chloromethane and hydrogen chloride. Okay, note that this is not hydrochloric acid, even though they share the similar chemical formula, but because this is not dissolved in water, it is not acidic. Okay, and this is the structural formula CH4 and my Cl2, okay, so the bond here will break and the bond between the two chlorine atoms will break, and then they will do a swap, which is why we call it the substitution reaction. So the hydrogen in this position will be substituted by one of the chlorine atom. So we'll obtain my chloromethane with the other byproduct of hydrogen chloride. Okay, so in this example, once again, the hydrogen in methane is substituted by a chlorine atom to form chloromethane, producing hydrogen chloride as well. So this reaction can continue going on given excess chlorine as well as UV light, and every single hydrogen atoms here can be substituted by chlorine atom. So initially I have methane, 4 hydrogen atom. With chlorine in UV light, I get chloromethane. One of the hydrogen is being substituted. If I carry on the reaction in excess chlorine and the condition of UV light, the next hydrogen atom can be substituted and I get dichloromethane. Di means 2, so this molecule here has 2 chlorine atoms. Carrying on the same reaction with excess chlorine and UV light, the third hydrogen can be substituted and I get trichloromethane. Okay, tri means 3, so 3 chlorine atoms. And finally, once again, same condition, I'll get tetrachloromethane. All hydrogen has been substituted. So now even if I continue to throw in more chlorine and UV light, nothing's going to happen because there's no more hydrogen available for substitution. Okay, so the products of a substitution reaction of alkane can be continuous. So in this case, methane, from methane alone, I can get chloromethane, dichloromethane, trichloromethane, and tetrachloromethane. So to obtain either one, we have to control the amount of chlorine very tightly. If not, we'll get a combination of all the different products. So to summarize, alkanes are hydrocarbons with the general formula CnH2n plus 2, CnH2n plus 2. As the molecular size of alkane increases, we learn that there will be a gradual change in their physical property, and namely it's their melting point and boiling point increasing. They become more viscous, so meaning less easily to flow, and also they become less flammable. Alkanes are also generally unreactive, but they can undergo combustion and substitution reactions. So take this chance to test yourself. List out the names and the molecular formula of the first 5 alkanes. Okay, recall how we use prefix and suffix to come up with the different molecular names. Okay, what are the conditions required for alkane to undergo substitution reaction? And what is the chemical equation of the substitution reaction between butane and bromine? So take this chance to test yourself to apply the concepts that you have learned earlier on for these questions, and I'll see you at the next video. Thank you.